109. And what we're doing today is not on the quiz on Thursday. So the quiz is specific to what we did on Monday. Okay? And tomorrow, is that rolling yet? Tomorrow, the one in the center, which is bimodal, has two peaks. Okay? But if we use, and again, all I did was, I'm copying and pasting this from the other lessons because this is important and the repetition is effective. If you use the mean as the measure of center, then we're using standard deviation for variability, the book synonym for string. If you use the median for the center, you're using IQR. Okay? And then we're describing the shape. Is it approximately normal or skewed?
Like, you're allowed to use the mean if it's skewed, though, right?
Oh, yes. Now, the issue is, I don't really like the way I set this up because I'm saying this looks like it's either approximately normal or skewed. It doesn't mean it's skewed if you use the mean. But if the data is skewed, it's helpful to use the median. But you can still use mean and standard deviation, but you have to be aware of it. See, if the data is symmetric, you're going to use the mean by default. Okay? So this is what Aiden asked about. When the shape is approximately normal, use the mean for center and the standard deviation for spread. Okay? If the data is skewed, you can use the mean as the center, but then it's probably a good idea to also to complement that and superimpose a box plot on the shape of the data. Okay? So, we're going to spend most of the course with data that is distributed approximately normally. We're on page 113, and they have these. You have this green histogram. And the green histogram on page 113, they superimpose this red curve over it. Okay, so it doesn't capture the data exactly. It's approximately normally distributed. So I drew this picture, what we talked about yesterday. Where you find the point of inflection of the curve is the magnitude of the standard deviation. So I drew these vertical lines. Mu is the center. Now when you see Greek letters, we're talking about the population. If you see Roman letters, we're talking about a sample. So this is a model, a theoretical model. We're using Roman letters. U is the center. The step is sigma. It's a standard deviation. And this sigma occurs right under the point of inflection for the graph. So this is one standard deviation. What would you do? You would copy and paste this distance and step to the left and step to the right. And we're going to tell you what the significance of that magnitude is. That's what we're going to get into in this section. So, these are just a couple things to keep straight. Whenever you see Greek letters, that refers to a census. It means you have all the data. It's rare. One example is the AP scores. Because when they give us the global AP scores, that's the AP score of every child that took the test. So we can use Greek letters to describe that data. If you have a statistic from a sample, then we use Greek Roman letters. So x bar is the mean, and S of x is the step. So when you see, overwhelmingly, you're going to see the Roman letters. All right? And we're just going to get into there's a picture on page 114. And they have two different curves on page 114. And you can see the magnitude of the step. But do you notice that in each curve, the width of the standard deviation is referring to the inflection point on the curve? Does that make sense?
Can you say it again?
If you look on page 114, and there's two normal curves showing the mean, mu, and standard deviation sigma. Yes?
Yes.
Above them, even though those curves have the standard deviations at different magnitude, you notice that that vertical line occurs at the point of inflection of the curve for both of them. So if you look at the picture on the right, where the step is smaller, it still occurs at the point of inflection. That's just one step to the left. And we're going to count out 3 steps to the left and 3 steps to the right to capture the overwhelming majority of the data. Okay? So, we're going to...
When you say steps, do we know what steps are yet from the center?
Well, there's the standard deviations.
Okay.
So we're saying,
So
like...
it'd be like it'd be like 3 standard deviations.
Correct. And we talked about this yesterday. This is the curve, right? And here's my center. We're talking about z-scores. You look at this thing and say, okay, about here is the inflection point. So if I go below that, that would be 1 step, 1 standard deviation. Then you count out whatever that magnitude is, you just copy and paste that distance, and that takes you to 3 steps left, or 3 steps to the right, 3 steps to the left, and that captures so much of the data that we don't bother doing this. This curve is asymptotic to the axis. There's still data points out there, far to the right, far to the left, but so few of them that we're not going to chase in. Right? So we're going to pause this and go over these questions 109. And what we're doing today is not on the quiz on Thursday. So the quiz is specific to what we did on Monday. Okay? And tomorrow, is that rolling yet? Tomorrow,
Join tech.
I want to read it.
138 and 139. And again, this is a little awkward, where it says picture page 139. Now that I have the electronic copy of the book, I'll paste the picture in there, but for today we can just go back and forth between the book. What height must the density curve have and why? Lexi?
0.25.
Because.
Because the area under the curve has to be 1, and the width is 4.
Correct. Width is 4. What do you multiply 4 by to give you 1? 2,500. So if it's a density curve, all density curves have an area of 1. And what that means is it's capturing 100% of the data. All right? B, what percent of the time will the light flash more than 3.75 seconds? So really what they did, I think it might be easier for you to do this. If you just think of that whole, that's how I wrote it up here, as a slide of one to the left. If I slide the whole graph one to the left, I would be aligned with the y-axis, and you would go from 0 to 4, which would make the problem easier to follow. Does that make sense? Like, what's confusing is they just picked the graph up and they moved it one to the right. But if you can move it back one to the left, you just add one to your answer. So then I'm saying, when would you be 2.75 seconds more than 2.5 seconds if you counted it from 0? Okay? And then what does that represent? So we rewrote this as 2.75 fourths. The width of the graph. 2.75 is the share of the width. And 2.75 is 11 fourths. And I took this fourth as the denominator, and I just rewrote it as a fraction out here. So 11 sixteenths is the area of the curve to the right of 3.75. So if you look at this, 3.75. What percent of the time will the light flash more than 3.75 seconds after the subject clicks start? Which would be more than that if you want to take away this, because 11 sixteenths is up to that cutoff, which would leave you 5 sixteenths to the right, and 5 sixteenths is 31.25% of the time. Does this make sense to you? C, what's the 38th percentile of the distribution? So you want to find where 38% of the graph is to the left. So it's going to be to the left of, in this picture, to the left of 3 seconds, yes? Because 3 seconds would be the 50th percentile. So it has to be to the left of that. So we're saying 2.52 seconds would be 38% of the data to the left and 62% to the right. So there's the slide again. 38% of the width of 4 is that, but I got to slide everything one to the right because the graph starts at 1.
Is there another way you can explain how to obtain the, like, get the 2.52?
Well, because if I'm looking at this picture, ready? 38%. If I look at this thing and say, okay, the 25th percentile would be 2. That'd be a quarter. Does that make sense?
Yes.
A quarter of the day is
Between
still.
2 and 3.
Yeah, it has to be between 2 and 3. So now we have to be more precise. So I said, I looked at it and said, suppose it started at 0. 38% times a width of 4 would be 1.52. You have this segment of 4, a width of 4. And you multiply that by 38% of 4, takes you to 1.52. But because the graph started at 1 and not at 0, I just slid it 1 to the right to get 2.52. This is not, this is just getting you used to interpreting the curve. These are not like AP exercises. They're a little bit. We go through 43? 45. Asks you to match these. Which one is the mean and median, and justify your answer? And again, the picture's not here on the PDF. So, the picture to the left, there's too many letters here. Picture A to the left is skewed to the right, yes? and the mean is sensitive to outliers. So the skewness to the right is going to drag the mean to the right. So the mean would be C, the point to the right, and the median would be B. And in the picture B, then the graph's symmetric, so the mean and median would both be B, right? And A and C would be the peaks, would be the moves. Now, '47 is more important. You're going to draw this curve all the time. So you need to get on board with this introduction to what this curve looks like. It's saying, you buy these potato chips, and the bag says there's 9 ounces of actual product inside the bag, okay? But there's going to be a spread there. There's going to be a variability. You don't have enough time for product control to make sure there's exactly 9 ounces in every bag of potato chips. So the data is telling them that the average, even though it's published at 9, they're actually putting a little more in there so that people wouldn't be, if there's a mistake, that they would cheat less people. 9 and 12 hundredths is the center, and the step is 5 hundredths. Which means what to you? We're just taking the curve and saying, here's the center. 1 step, 2 steps, 3 steps. You're not going to write all this out. You're not going to write the top line, but you're going to write these 2 lines. Here are the z-scores, the standardized scores. 0, dead center. 1 standard deviation to the right, 1 to the left, 2 to the left. And then you just literally count by increments of the standard deviation, which they told you are 5 hundredths. So you're here, count up by 5 hundredths, count down by 5 hundredths. And then what we will learn in the back half of section 2.2 is what share of the curve is to the left of those cutoffs. But we're not there yet. We're not quantifying the area of the curve. Okay? Anybody got a question? So, we're going to go here. We're going to cross-reference with that paperback book what you expect to see tomorrow. Or, I'm sorry, on Thursday. So, this is on Google Classroom. And these are the topics. There's going to be 6 questions on the quiz on Thursday. They're going to be this is the topics that are on here, yes? So what I'm suggesting you do is, we got 4 minutes, take a look at the paperback book and see where you can find these topics in the book to have an alternate resource of what you're going to be assessed on Thursday. You have some familiarity of how that paperback book is set up. Tomorrow we will return your 1 test to you and go over the 2-1 alpha homework.